Good morning and welcome back to Server-Side Web Development. This is lecture 4. Today we're going to be talking about databases. So we're moving away from PHP and we're moving on to databases. And along with databases, we'll be learning about SQL, which is a new language which we'll be learning. We'll also be introducing the participation exercise, which is Movie Mayhem 1, as well as the Hybrid 2. We'll talk about that. And then we'll have your next exercise, which is Sociology DB 1. So those are the topics we're covering today. Are there any questions before we get started? Okay, doesn't sound like there's any questions, so let's jump to it. Databases. All right. So a database is an organized collection of data managed by a database management system. So in the past, we've had to deal with data. We've stored it in, say, arrays or objects, or maybe even in an external file, maybe in a JSON file. Data can also be stored in just files like HTML or a Word document. These are all ways of storing data. But eventually, what everybody comes into play is if you want to scale the amount of data you're managing, you're going to have to rely on a database of some sort. So, some of the advantages of using a database is scalability. That's what I just talked about. So, if you're going to get more data with the file management system, we're storing everything into files. As the data grows, the file grows and becomes more and more difficult to manage, right? So databases have better scalability. And their databases are also easier to manage. And a lot of that management is handled by the database management system, which is what we're going to be talking about here in a moment. Because of the management system, they handle all of the difficult part of making sure that the data is both accurate and secured and we can get access to it and it can be scalable. So again, this is all the rest of these are all about the database management system, what they gives us. So we get better accuracy of our data. The database management system will keep track of what data is being entered in to make sure it's accurate and to make sure that we're not putting in bad data. It's also more secure because database management systems are generally secured behind passwords and firewalls and all that. It does add a level of security that protects the data. Not anyone can get access to it, even people of the same company. With database management systems, you can provide different levels of access. So some person might just be able to read it while other people may be able to change the data. And the last one is a better data integrity. Again, along with that accuracy, database management systems help keep track or help make sure that the data is following a certain pattern, is making sure that it's being entered incorrectly. So we're not worried about having the bad data, right? So those are some advantages of using databases. Now let's talk a little bit about database management systems. So, database management systems, or DBMS, are programs that will open database files and manage database tables. When we talk about databases, we might refer to them as like Oracle or MySQL or MS SQL. Those are not databases, those are database management systems, but we tend to use those synonymous. The database is what the management system works with, and the management system can have multiple databases in it. So, and that was the next slide, right? They can manage multiple databases. There are different types of database systems. The two most popular ones are the relational database systems and the NoSQL database systems. So the relational database systems is what we'll be learning in this class because we'll be learning MySQL, which is a relational database. NoSQL is in a newer way, a newer form of databases, and they're basically called that because they don't use the SQL language, whereas almost well, all relational database systems use a version of SQL, and they don't. And they work on a very different system. They work sort of on a document system where things are more fluid. There are some advantages to using NoSQL. And if you are in the web production course this term, we will be learning Firebase and Firestore in that course, and that is a NoSQL database. All right, so relational databases, again, that's what we're going to be learning in this class. All our DBMSs have common elements. That's what makes them relational databases. They all use tables, keys, and relationships. So in a relational database, we have tables to represent our data. So each data group will be represented in a table. You can think of a table kind of as a spreadsheet where it has columns and rows. And we'll go into more detail with that in a little bit later. So again, all of our relational databases will have tables and keys. Keys are sort of ways of representing certain rows in a table. And then each table has a relationship with one another. We won't be spending too much time on the relationships because that has to do with more database design, which we won't be spending time in this class doing. All right. The next thing that keeps the common element is that all relational databases use a form of the structured query language, which is SQL. So it is a language, it is a computer language that allows us to make requests to the database to get specific data. All right. So again, tables are like spreadsheet data with columns and rows. Keys are row identifiers. They'll typically it's typically a number. Again, it allows us to identify a specific row in a table. And the relationship is how the data is related. So what we often have in a relationship is a one-to-many relationship. So for example, an order, if you were in a shopping cart, for example, an order would only be related to one customer, but a customer can have many orders. So that is a one-to-many relationship. And that's kind of what we look at when we're working with data in relational databases, is these relationships between the data. All right, so one of the big advantages of all these similarities is that it makes it very easy for a developer to move from one relational database to another. So in this course, we're going to be learning the MySQL relational database, which is one of the most popular databases out there. But even so, if you were to get a job working in a different, with a company that used a different database system, like say Oracle, which is also a relational database, it will also use a version of SQL. And what you learn in this course will translate very well into working with that database as well. It's going to be very similar because, again, all relational databases work very much the same way. There's just some minute differences among them. All right, so let's talk a little bit about MySQL because that is the database system that we're going to be using. So MySQL, again, is the most popular, it's the most popular open source RDBMS, and it is one of the most popular RDBMSs out there. It is also a crucial part of the AMP stack. So in content management systems, I believe you use the app like MAMP or WAMP or XAMPP. The reason why they all have that name is because of the AMP stack, which stands for Apache MySQL PHP. That's what that's referred to. That's the AMP stack. And the first part is just whatever operating system you're working on. Are you working on Mac? Are you working on Linux or Windows or whatever version of operating system they want to refer to? But the AMP part, again, that's the crucial part. And again, MySQL is a part of that stack. Now, MySQL can be used with many different languages. Even though the AMP stack refers to PHP, it can be used with many different languages other than PHP as well. So again, what we're learning here in class can translate to other areas or other languages. Now, the next thing I'm going to talk about is MariaDB. Now, MariaDB is a community-driven forked version of MySQL. So, and the reason why there's both MySQL and MariaDB is because MySQL was a community project and was open source. It's always been open source and was created that way. But then back in, I believe it's around 2008, Oracle bought MySQL. Well, actually, what happened was Sun Microsystems bought MySQL, and then Oracle bought Sun Microsystems. So now Oracle owned MySQL, and Oracle is one of the biggest database companies in the world because it has the Oracle database. So many people were worried that because MySQL was a direct competitor to the Oracle database, they were worried that Oracle would then kill MySQL. So the creator of MySQL, the original creator of MySQL, decided to take MySQL, its whole open source, and fork it and create a new database that would be truly open and would always be free and available for anyone. And that's what he called MariaDB. And MariaDB continues to be developed, and it is nearly fully compatible with MySQL. They work very hard. The team there works very hard to make sure that any changes Oracle makes to MySQL are also changed to MariaDB, so that anyone who wants to switch to MariaDB can do that very seamlessly. It's just like, oh, I jump here and then there, and it's basically the same thing. So I want to bring this up because if you're working on your own or at a company and the hosting space that you has doesn't have MySQL, but they have MariaDB, just note that they're almost the same thing. And a lot of people just kind of consider them to be the same database. Even though they are slightly different, they are essentially the same. All right, so that's kind of a big, kind of in a nutshell, what databases are and what we're going to be using in this class. Are there any questions before we jump into actually SQL? Okay. Again, we're not going to be spending too much time on database understanding databases. We're going to be more working in this course with SQL and how we retrieve data from databases. So let's go ahead and take a look at SQL. So the structured query language, or SQL, is a scripting language for relational databases. Okay, again, all relational databases use a version of SQL. And what we're going to be covering in this course is so basic that pretty much any relational database will be using what we're learning in this class. So again, what you've learned in this class can be used for any database system, not just MySQL. Now, the one thing you need to know is that SQL is a declarative language with very few commands. Right? It's actually a very, very small language, and it's been around for decades. And it will probably stay around for a very long time because it was invented to be very small and very precise. And its declarative nature of it makes it so easy to learn and use. Now, when we talk about declarative languages, we're talking about a different type of language than what we've been learning in PHP and JavaScript. So with PHP and JavaScript, those are programming languages in which that we set out a set of instructions for the computer to follow, right? Do this, then do that, then do that. We're telling the computer exactly what to do each step of the way. Well, with declarative languages, we tell the computer what we want, and then the computer figures out how to get it. So instead of saying, let's see if I can think of a good example here. So instead of saying that I want to get all of these colors from this array, in PHP or JavaScript, we would say, okay, I got to get the array, and I'm going to use a loop. I'm going to loop over each item and output each item in that array. And that's how we would do it, right? We'd write the loop, we'd do that. In SQL, we just say, give me all of the colors in the array. And the computer would figure out how to do that, and it would give us the result. So because of its declarative nature, it makes it much easier. And in my experience, most students really like SQL because it is such a breath of fresh air to the programming side where you have to think each step, where this you just have to describe what you want. All right, so with that, SQL has 4 basic tasks that we need to work with, or that we're going to be working with. And they are create, read, update, and delete. Now, I've capitalized each one of those because this spells the acronym CRUD. And it sounds like a terrible acronym, and it really is, but you'll hear CRUD a lot when you're working with databases or any web application, because these are the 4 common tasks you'll do with data. You'll either create data, you'll read data, you'll update the data, or you'll delete data. Now you'll notice in the orange, there's insert, select, update, and delete. Those are the actual commands that we'll use in SQL to accomplish those different tasks, which is create, read, and update, and delete. All right, so in this lecture, we're just going to be focusing on the select, just the read in this lecture. Next week, we'll cover the other three, create, update, and delete. All right, so let's go ahead and look at our first, we'll talk about our first type of statements inside of SQL, the select statements. Again, this is just reading data from the database. This is what you're going to be spending most of your time doing when you're working with databases, which is reading the data. All right, so the select statement is used to retrieve information from one or more tables. So we use the select statement to say, I want to retrieve data or information rows from a table. And the structure is like this. We do select, and then the columns of our table we want to retrieve, the keyword from, and then the table name. That's it. We write it like that, and again, the database will figure out how to get it for us. Let's actually look at the real thing. So here is an example of a query. So right here is the actual query. Again, the select keyword. This is how we retrieve. Anytime we want to retrieve data, we will use select. So we select. Now this asterisk refers to, it's a little shorthand, and it refers to retrieving all columns. So we want to retrieve all the columns from the table. And remember, if you think of a table like a spreadsheet where it has columns and rows. So we want to retrieve all of the columns from movies. Now we don't have anything after this, okay? We have just this. So this is going to retrieve all of the rows and all of the columns from the movies table. And it's going to bring it back to us so that we can see that data. Now we can specify specific columns. So again, this is retrieving all the columns, but we can specify certain columns using their column names, right? So we have a movie underscore title, and we have a director. Those are 2 columns in our movies table, which we can retrieve. And it's just going to retrieve those and not all of the columns. So we can specify, we can limit the data that way. All right, so another couple other things I want to point out. Note that we are capitalizing select and from here. Those are keywords inside of SQL. Now, SQL is not case sensitive, right? Meaning that we do not have to capitalize these. We can keep them lowercase, you can mix the casing, it doesn't matter. SQL understands. But common convention states that we will capitalize any of our keywords or our command words inside of SQL to separate them from column names and table names. All right, any questions about your basic select statement?
I have a question.
Yes.
So those statements, where do they go? To the database or in the in a PHP language?
Okay, so yeah, how do we send these queries? Right, we haven't gotten there yet. So for the first bit of learning these databases, we're going to be using PHPMyAdmin to handle all of our queries. So we're going to send our queries using PHPMyAdmin, and it's going to bring us back our results. And so for your assignments, and I will demonstrate this at the end of the lecture before I let you go, So you can see how this works, because for your assignments, that's what you're going to be doing. You're going to be using phpMyAdmin to submit all these queries. After we're done with our database lectures, which we'll have just next week will be the last one. We're just going to be doing this for 2 weeks. Then we will demonstrate how we can use PHP to combine them, or how we can use PHP to send these queries to the database and then retrieve them back. And we'll be using what's called PDO to handle that. Again, that's a couple of weeks away. All right. All right. Any other questions? Any other questions? All right, so let's go ahead and look at how we can limit the number of rows or filter the select statements. All right, so the where clause can be used to filter rows or to limit the number of rows we get back. So rather than getting back all the rows, we only want to get specific rows back. The where clause is followed by a condition that tests against each row. So think of this as kind of like an if statement, right? Where we're limiting, we have all these rows, and then we want to limit it down to just the rows we want. All right, only the rows that meet the condition will be returned. The other ones will be not returned. So let's take a look at what a where clause would look like. So here we have a little bit more complex select statement, but we still start with select. And here we have our different columns. Now we have 3 columns here. Take note, I didn't mention this before, take note that there's a comma between each column name. I also want to point out that I'm using backticks here around the column names and table names. This is not a required, I should say. As long as there's no space between in your column name or table name, the backticks are optional. But if you were to have a space in your column name or table name, then the backticks are required, because a space, SQL doesn't understand the space. So we're using the backticks here to wrap around it. Now, I do want to mention these are backticks, not quotes or single quotes. They are backticks. Don't confuse that, because if you were to put single quotes here, it won't validate. All right, so there we go. We have our select with our columns, and then we have the from table. Here's our movies table. Now here is our where statement. So our where clause is checking the condition. So the condition we're looking for is the condition movie underscore ID is greater than 10. All right, so we're looking for any row that has a movie ID that is greater than 10. So only those rows would be sent back. All right, and we have another one down below. Again, we're doing our select statement from movies, now our where. Here we're doing where movie underscore title equals labyrinth. So it's going to go through each of the row and see which movie has labyrinth as the value inside of movie title. And it will retrieve that row or rows, depending on how many there are. All right. Any questions about the where statement? We're going to get to see it in action a little bit more. Okay.
How do we differentiate the rows and the columns?
Okay, so good. Let's go back here. So that's a good question. So remember that, think of a spreadsheet. If you've ever worked with a spreadsheet, we have a table here. I'm just going to draw this out. All right, and then we have in the table we have columns, right? And we have rows. So this is a column, 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 and these are rows. All right, so columns are the data, are basically what type of data is being stored. Okay, so this is a first name, last name, address, something like that. The rows are the actual instance of the data. So this is John Smith. at 123 Main Street, okay, and so forth. So the rows are the different instances of the data, and the columns are the type of data that's stored in the table. So again, every table will have a column and rows.
And how I created this table is like when.
So how would we create these tables? So there are SQL commands to create these tables. That's not something we're going to cover in this course. You're going to be provided with for all of the assignments in this course, you will be provided with the databases and the database tables.
Okay.
So you won't have to worry about that in this course. If you're interested in creating your own tables, you can research it. It's not that difficult. Mostly though, you would use some sort of software to do that, like PHP My Admin, to create your tables and insert your data.
Okay.
All right. Any other questions?
Just to understand like the logic of this, when okay, because I'm working on database, I will not return nothing. It's just how this information will work with my front end, my page.
Right. So how does this tie to, say, a web application or whatever? So for example, so we have our database here, and what's going to happen is the queries that we're talking about will be sent to the database, and they'll be sent by PHP per se. So like PHP is going to, we have PHP, and it's going to send the SQL to the database. And then the database is going to send that result back to PHP. And it's going to send it back as, or PHP is going to retrieve it as a multi-dimensional array. And then from there, PHP can then manipulate it and display it on the page. Does that make sense?
Makes sense. So we are in this middle, like we are doing the SQL part to send to that database.
Right. So right now we're just learning about how to write the SQL statements. And then in a couple weeks, we'll learn how to get PHP to send the SQL to the database.
Okay.
Yep. We're kind of taking a break. We're taking a detour to learn how to write SQL statements. And then we'll go back to PHP and learn how to have PHP write those or send those SQL statements to the database and retrieve its data back. Right? Any other questions? Okay, so let's go ahead and move on to wildcards. All right, so in the previous where examples, we saw that we could use a greater than and an equals. You can also use less than, and there's also a not equals in there. But we're going to talk about another operator, which is the like operator. And with the like operator, it makes it possible to search for only part of a string or part of a value in the database. So like in the example where we had the movie title equals labyrinth, it would only return the row that had the exact value of labyrinth. But what if we were looking for all the movie titles with the word the in it? Well, we couldn't use the equal sign then because it wouldn't return anything because there's no movie with just the word the in it. So that's where the like operator will come in. And along with the like operator, we would use the wildcard, which will serve as sort of a placeholder for one or more characters. So we'll be able to use that wildcard to kind of insert, kind of say, okay, I'm looking for the word the, and now anything that comes after the word the is okay. And that's where the wildcard would come in. Now we have two types of wildcards. The first one is the percent sign, and this is generally the one we use the most often, and this will represent 0 or more characters. So anytime we want to search for a specific word within a larger value, we would use the percent sign, and we could put it on either side of the word we're looking for, and that would say, okay, look for this word anywhere in the title. The other wildcard is the underscore, and this represents just a single character. Honestly, I've never had a reason to use this one, but it's good to know that if you're looking for something that specific for just a single character, maybe if you're looking for a specific name and you didn't know if it started or ended with an S or something like that, maybe that would be very helpful. All right, so that's wildcards. Let's take a look at an example. So here we have, again, another select statement. We have another select statement. We have, again, retrieving some columns from the movies table. Now we're doing where movies title, like, and then we have our string here. So remember, the like clause allows us to sort of search for a string within a string. And then we have a set of wildcards. So here we have the percent on both sides of the A. So what this means is we're looking for any movie title that contains the letter A anywhere in its title. So it can be at the beginning, it could be at the end, it could be in the middle. Because of these wildcards on both sides, that allows us to do that. In the next example, again, it's very similar, except for in the next example, we have G with just a percent sign at the end. So this is saying, give me any movie title that starts with the letter G. Okay, because of that percent sign coming at the end, because there's nothing at the beginning, it means that the string must start with G. Right? Any questions about using the like operator?
These keywords here, we are searching for, is it case sensitive?
No, it's not case sensitive. Most SQL statements are not case sensitive, so it really doesn't matter if you have capitalized it or lowercase. SQL will bring back both results.
Okay, for this case, for these two examples, the first example, we are searching for a word includes lowercase a, but it doesn't matter lowercase a or
right. It doesn't matter.
Okay. What if we want to search like capital sensitive word?
You want to look for you want to find ones that are only capitalized. I'll have to look that up. I don't know offhand about the case sensitivity. Okay, I'll get back to you on that one.
Okay.
In this case, for example, if I use more than one letter, I can like compound a word, and it works also.
Yes, yeah. So you're right. In these examples, I'm just using one letter, but you could use whole words. Yep.
Okay.
Or multiple words, even. All right. Any other questions?
Yes. In the second example, the percentage sign is after G, like at the end. What if we put before G? Would it mean that we are searching for the movies that end with letter G?
That's exactly right. So if we were to put this percent sign at the beginning, it means that we would look for a movie that ends with the letter G.
Okay.
Yep.
And what about if you're searching for a number? Is it the same way?
If you're searching for a number, yeah. So numbers, like, really just works with strings, not so much with numbers.
Okay, so if I want to search something with numbers, how do I do that? Like,
okay. So you're searching inside for like a number within a number. I'll have to look into that. Sorry, I don't know that one offhand. Because usually I use like with just strings.
Okay.
But I'll look into it. I'll get back to you.
Okay.
Those are excellent questions. Any other questions?
Thank you.
I have a question. So if, for example, I had this show title 13 Reasons Why, would the 13 in that title count as a string, or would it be counted as a number?
No, that would be a string. So because inside a database, because that would be entered in as a string, so 13 there isn't really a number. So remember, the big thing to think about is when we talk about numbers, especially related to databases, uh, if we need to make calculations with it, then it needs to be a number. Otherwise, we'll store it always as a string. So phone numbers, for example, even though it's a number and you think we'll store it as a number, generally we'll actually store it as a string because we're not going to be doing calculations on a phone number. Right. So in that case, 13 reasons why, or that is, again, it's part of the title. So it's going to be a string.
Okay.
All right. Any other questions? All right. Let's move on to complex filters. So in the examples we've seen so far, we're just looking for a single condition, but there are ways of creating more than one condition. And that's using the and or operators. And these can be used to combine conditions together. And now the and operator will allow us to display a record if all conditions are true. So, this condition must be true and this condition must be true. If both of those are true, then the record is returned. The or operator, of course, works as if any condition is true. This one or that one is true. Either one is true, then the record gets returned. So let's look at an example here. All right, so here we have, again, another selecting from the movie where movie title is like. So this is saying it will end with T. So we're looking for a movie title that ends with T and its director starts with Luke. Okay, so this one is, again, and. So both of these conditions must be true. All right, in the next example, we're looking for where director like Luke or director like Dean. So these starts with Luke, starts with Dean. So in this case, if either one of these are true, then the record will be returned. Does everyone see how that works? Now, there's one thing I do want to point out here in this second one example. Notice that we're retrieving from the same column, director, director. If you ever find yourself making a request from the same column like this, you must use or. If you were to attempt to use and, you will never get anything back because each column can only store a single piece of data. And so if this was an and, it would never come back because in no case would both of these be true. All right, so if you're retrieving from the same column, you have to use or. All right. Any questions about and or? Okay. Let's look at sorting select statements. So when we get these records back, they will generally be returned into whatever order the database feels like giving it to us. Generally, they're in the order that they're entered into the database, but that's not always true. So they just kind of come in some random order. So sometimes it's very useful if we can sort those select statements. And we do that using the order by clause. And this is used, again, to sort results. Now we sort results by a column. So we specify which column that we want to order by, or columns. So you can sort by multiple columns if you wish. And columns can be assorted by ascending or descending order. And you would use the ASC or the DESC clause to specify which order you want to order them at. Now, with that said, by default, columns will be returned or sorted in ascending order by default. So very rarely will you ever use this, but you will need to use this to reverse that default. Let's take a look at an example here. So here we have, again, we're selecting our movies. This time we're adding year to our column. So movie ID, title, director, year. And we're getting it from the movies table. Now, we don't want to just get these movies from any order. We want to get them in order by year. So we're going to do order by the year column. Now, note we didn't add it. We didn't specify any what order, ascending or descending. So this will be in ascending order, which means that the oldest movie will come first. Because obviously years, we're dealing with year dates. So the oldest or smallest year will be the oldest date. So the oldest movie will come first. In the next example, we're sorting by their movie title, and we're doing it in reverse alphabetical order. So we do order by movie title, the column, and this time we do descending. So this will come from Z to A. Right? And that's pretty much it for sorting our columns or sorting our rows. Any questions about order by?
I have one question. If we do not use the order by, does it by default give us all the values directly, like the top 10 values, or does it still order by something like the first column, like movie ID?
No, again, it doesn't order specifically on anything. It will bring back all of the columns it's supposed to, or all the rows it was supposed to. So again, this is order by is not filtering or changing the result. It's not limiting the results in any way. So if we didn't have this, we didn't have the order by here, we would get the same results. The order in which those results come will be different though. And by default, the database, again, doesn't send the columns back in any specific order because it's just the order that the database retrieves them. Now, generally, it's in the order that they were entered, but again, that's not always the case, and you can't rely on that.
Okay.
Okay. For the first example, we select movie ID and the movie title and the director and the year. They are columns, right?
Right.
And from movies, the movies is the table.
Correct.
And the result we are getting is the ID, title, director, years, and they are in a row. And
yes, yeah. So
what do we get for the?
Yeah, I should probably really add pictures to these slides so you can see what these would look like. So I'm just going to draw something out here. I'm going to do some shorthand because I don't have a whole lot of space. So this would be something like ID, title, director, and year. So something like that. So those are our columns. So this is sort of, imagine this is the table we'd get back. And then inside of here would be all of the movies, because we haven't limited our movies in any way. So all the movies in the database would come back with these columns. And they would be ordered in by year. So the oldest year, say 1950, and then 1951, and then 1952, and so forth. So all of the movies would be ordered in that way because we've had this order by.
Okay, so we're gonna get a new table.
Yes, you would. Okay, so there's been a lot of questions on what we're going to get. So I'm going to halt the slides here, and I'm going to jump over to my other screen here, and I'm going to kind of show you what we would get back with working with these databases. So I am at my PHP My Admin here. If you want to, well, you can't really follow along because you probably haven't installed the databases yet, but I've got the database already installed on phpMyAdmin here, and I'm going to kind of walk through just some real basic SQL so you can see what it looks like. I'll come back through and do this again so you can watch, so you can know how to do this part. Skip that. All right, so I'm just going to grab a database here. There we go, and Movie Mayhem. All right, so the Movie Mayhem database, that's what I'm looking at right now. This is what your participation exercise, this is the database you're going to be using. And all of the examples we've been seeing on the slides are actually from this database as well. All right, so I'm going to just write a very basic SQL statement. And again, this is phpMyAdmin. This is one of the more popular web-based database systems out there. There are also native apps that allow you to work with databases as well. All right, so right here is a little SQL box. So I'm just going to write out some SQL. I'm just going to start with something very basic select statement. So select star from, and then I'm going to do from movies. All right, like that. So this is all I'm going to type. Select star from movies. Let me make this a little bigger so you guys can see. All right, so there's that. I'm going to go ahead and click go. And when I do, shrink this back down, this is the table I get back. All right, now this is being displayed as a table inside of phpMyAdmin. But what is coming back is the data from the database. And phpMyAdmin is taking that and displaying it inside of HTML for us to see visually. But again, it's the data that we want to see the results, okay? So we're seeing these results. Now you can ignore this column right here where edit, copy, delete. This is something phpMyAdmin adds, but here is this other data. So here are the different columns inside of the table because I didn't specify, I just said give me all the columns. So we have movie ID, movie title, director, year, and genre ID. Those are all inside of the movies table. Now, if I were to change that, say if I want to specify to just be movie titles, movie title, there we go, and then I click go. Once it's done loading, now I just get the one column back, but I'm still getting back all of the movies back. All right, not just a few movies, I'm getting all the movies back. So if I want to limit that, if I didn't want to have all those movies, I could add the where clause. So I can say where movie ID equals 3. Okay, so I'm just going to say that movie ID equals 3. Now, movie ID is the key of this table, and it's specifically it's the primary key. And we're not going to worry, you don't have to worry too much about primary keys. That has to do with more database designs. Again, we're not going to be using that. But the one thing you have to remember about primary keys is that they are unique on the table. This value 3, there should be only one row with the value 3 in the movie ID column for this table. So when I click go, I should get back only one result. And I did. It's right here. It's so small, I almost missed it. One row, and I'm still just have movie title, so I just get Alien. So that is the movie with the ID, movie ID of 3. All right, so let's go back. I'm going to do one more change here. I'm going to take this where clause away, and now I'm going to do that order by. And I'm going to order by the year. Now, note, I'm still just retrieving title here. You can sort by a column that you're not retrieving. That is allowed because, again, they're independent of each other. Okay, so I can, let's actually add year. I can click go. This will actually produce the results. So this is pushing the results in year order, but we're not really able to tell that without the year. So I'm going to go ahead and add the year so we can see that. I'm just going to add the year column here. I'll click go. And there we go. So now we can see that the oldest movie in our database is Star Wars, which came out in 1977. And the newest one is Her, which came back, actually, so one thing that you do need to know is even though this is coming back with all the rows, because we haven't limited it in any way, MySQL still limits it to 25 rows. So you do want to make sure that when you're working on the assignments to switch this, because I believe there's 28 rows in the movie database. Yeah, so it goes all the way to 2016. So you just want to make sure you switch that. Okay, so that's kind of a rundown of how we can send queries and get data back. Now, again, this is not data we can really use or manipulate ourselves on our own websites. And that's because we're just practicing writing the queries here. In a couple of weeks, when we talk about PDO, then we'll be able to send these queries that we're writing to SQL through PHP. And then we'll retrieve that data back from PHP, and we'll be able to display it on the page ourselves. All right, any questions?
Can we order by 2 columns?
Can you order by 2 columns? Yes. Yeah, that's a good question. Let me show you that. So let's go ahead and let's see if I can. All right, so right here. So we're going to, because we're only retrieving the movie title and the year. Okay, so you can see right here in 1997, we have 3 movies that came out in 1997, and they are not in alphabetical order by their title. So we have Ganta, I don't know how to pronounce that one, then The Fifth Element and Contact. All right, so those are not in alphabetical order. So let's go ahead and sort them so that we sort by year and then by the movie title. So we'll do that by adding a comma after year, and then we'll do movie title, like that. So we have movie title, year, from movies, order by year, movie title. So it's going to order by the year first and then by the movie title. So I'll click go. And we're not going to see a whole lot of change, but right here, that's at 1997 where we have those 3 movies. We can see that they now have been reordered into alphabetical order. Okay, so that's how you can sort by more than one column.
That is very cool.
Okay. All right. Any other questions before we move on? All right, so let's talk about limiting results. Now, I've used the term limiting a lot to kind of in synonymous with filtering. And I apologize, probably shouldn't be doing that because there is actually a way to limit the number of results that gets returned. And that means not filtering the results. That means saying, okay, I only want 5 results back. And that's what we're going to do here. So that's what we use the limit clause for. So the limit clause can set a specific number of rows to be returned. I only want 5 rows, or I want 10 rows, or I only want 1 row returned. No matter how many are supposed to be returned, only return 1. So that's what the limit clause does. The limit clause can also be used with pagination. So you can specify not just how many rows to get back, but when to start. So if the results would have sent me back, say, 20 rows, but I only want 5 rows back at a time, but I want the next 5, not the first 5, but the second 5 rows, I can do that through pagination inside of the limit clause. The limit clause can also be used for update and delete to limit the number of rows affected. And we haven't talked about update and delete, and I'll talk about that again when we discuss them. Something else that's not on our slides here is generally if you're going to use the limit clause, you'll want some sort of ordering involved so that you generally know which set you're going to be returning. All right, so let's take a look at some examples here. So here, we at the top one, we have a select. So we're selecting all of the columns. So remember the asterisk here retrieves all of the columns from the movies table. Now we're ordering by year in descending order. That means the newest movie will come first. And then we are limiting it by 5. Okay, so we're getting the 5 most recent movies. That's essentially what we're saying. So give me the most recent movies first, and then limit to just 5 of those. Now where the pagination comes in is we can add another number there. So this one is giving us the 5 most recent movies after the 10th movie. So we do select star from movies, order by year descending, just like above, but this time we go limit 10. So this is saying after the 10th movie, then give me the next 5. Okay, so that's where the pagination comes in. Any questions about limiting? All right, so the next one, this next result is filtering multiple values. So in our previous examples, we saw where we used the where clause. We saw we can use less than, greater than, equals. We also have the like operator. All of those are looking for one specific value. I mean, the like operator allows us to search within a value, but we're still looking for one specific thing. But we have the in operator allows us to basically search for multiple values within a specific where clause. So the in operator will use an in place, can be in place for the or clause for a column. So if you wanted to say, I wanted to look for multiple years, movies from say 1980, 1990, and from 2000. Okay, so I want those movies. You could use the or clause for that, right? So I could do where year equals 1980, and then I would do an or, and then I would do year equals 1990, and so forth. I could do that. Where the in clause allows you to do that in a little bit shorter syntax, and we're not having to repeat this all the time. And we do that by providing a list of values. So let's see this in an example. So here is the example of the in clause. So we have select star from movies, where year in, and then we provide this list: 1986, 1997, 1999, 2009. So here is a list of dates. Now, if any of these dates matches the value in year, that row would be returned. Again, we could do this with the or, but this is significantly shorter. All right, any questions about using in?
So this has to be only in a single column here.
Yes, it can only be in a single column. Yep.
Okay.
Michael,
Yes.
if you don't have a movie in 1999, for example, what will happen?
So right. So this isn't saying that this was right. It doesn't matter. So it's going to look for any row, and if the row has any one of these values, it will be returned. It doesn't matter if no row has one of these values. Those are the rows we're looking for. It's going to return just those values.
Okay.
Can we do a range, like between 1986 to 2009?
You mean do a range? Yes, there is a range. I'm not showing it in the slides here. So you're right. There is a between that allows you to kind of do a range, and you can use that with numbers. It doesn't really work with strings, but with numbers and dates for that matter, you can do a range where you do between. It is on the content pages. I don't know why I don't bring it up in the slides, but yes.
Okay.
You can also do it using greater than and less than.
Could we use in for strings, certain strings?
Yes, you can. Again, you'd be looking for specific strings. So say, for example, we're looking, if we had a column that was colors and you knew exactly which colors you were looking for, then yeah, you could do that with strings.
With strings, do we need like quotation marks for the keywords?
Yes, that's a good question. So just like in JavaScript or PHP, strings are represented with any characters are in quotes. You can use single quotes or double quotes in SQL.
Okay.
All right, any other questions? All right, so we're going to talk about our last little topic for today with SQL, and that has to do with subqueries. Now, subqueries can take a little time to get your head wrapped around, so I'll try and go slow here. So a subquery is a select statement within another statement. So imagine, well, right now we only know select statements. So imagine that we wanted to get a piece of data and then we want to get another piece of data to use in our previous statement. Well, that's where subquery does. It's like making another select statement, keeping that data, and then using it for the previous select statement or the other select statement. But we can use it for any statements, not just select statements. So a subquery can be used to get data from another table or from the same table. So if we wanted to get a different bit of data that will be used for a statement, we can do that. Okay, let's see an example because it makes more sense than me describing it. So in this example, we want to retrieve all of the movies with the genre ID in the fantasy genre. Okay, so this will make more sense if I show you the table so you can see what we're looking at. So I'm just going to jump back to our database here. Oops, I'll get back to that screen here in a moment. Let me go back to our Movies Mayhem database. I'm just going to click here. So you see here, here's our databases. We have two tables in this database. We have a movies table and we have a genres table. We haven't really talked too much about the genres table. But let's say that we have, let's take a look at what the movies table looks like. So if I were to click on movies here in PHPMyAdmin, it's going to show me all of the movies that are in there. But I'm going to go to the structure. And what the structure does is it shows me what the table would look like structurally. What are the columns? So it has 5 columns in it. It has a movie ID column, a movie title column, a director column, a year column, and a genre ID column. Now, this genre ID column is what is known as a foreign key. And a foreign key is a way of connecting one table to another table. In this case, we're connecting the movies table to the genre table. And this allows us to basically set a number here that will then coincide with a number in the genres table, specifically the primary key. All right, so I'm going to go to browse here, and I'm just going to look at one of these rows. So right here at the very top is Labyrinth. It's the first movie in here. Note that its genre ID number is 1. Okay, so Labyrinth is 1. Now, if we were to go back to our movie database, and we were to click on the genres table, we can see that in the genres table, we have 2 columns. We have a genre ID column and we have a genre title column. Now, this genre ID in the genre table is known as a primary key. This is that unique identifier for each row. And in the first row is the number 1, which is labeled as fantasy. So again, this is what that 1 on Labyrinth was pointing to. It was pointing to the fantasy genre. So in our slide, go back here. In our slide, when we're asking to get all of the movies from the fantasy genre, that's what we're referring to. We want all of the movies with the genre ID of 1, where the genre ID equals 1. Okay, so let me go back here. Let me write an SQL query for that fact. Whoops, let me go here. Go here. All right, so if I wanted to get all of the movies into fantasy, right, I could do select star from movies where genre ID, add my backticks here, equals 1. Okay, so this is what I'm looking for. I'm looking for all the movies with the genre ID of 1. And I can click go. And you can see that Labyrinth shows up. We said that Labyrinth had the ID of 1, and here's all of the other ones. Now, we know that this is all of the movies with the fantasy genre, because we know that the fantasy genre ID is 1. But in larger databases or databases that you're unfamiliar with, you might not know what the ID, the primary key of the fantasy genre is. So you would need to look that up. And you would need to look that up without manually doing it like we did here, where we looked at the genre table, we said, oh, there's fantasy, it's genre ID 1. So we want to be able to do this in a single query. So that's where subqueries is going to come and help us. So I'm going to write here. So instead of putting 1 here, I'm going to add that subquery where I write a second query. All right. So let me actually, I'm going to comment this out. And I'm going to write the query to get back the ID for the fantasy genre. So I'm going to do select here. I'm going to do what I want back is the genre ID. And I'm getting this from the genres table now, where the genre title equals fantasy. So I'm going to do fantasy like that. Okay. So this first query is commented out, so it won't execute. And this is my other query. So this is my getting back the genre ID. So I'm going to get there. And you can see back that I'm getting genre ID and I'm getting 1. That's all I'm getting back, just the 1. So that's what I'm getting. That's what I wanted. This is that number 1. That's the same as the value we want to put in my genre ID in my first query. So what I'm going to do is take this second query I wrote and put it inside of my first query like this. Now, these parentheses are optional, but it's a good way of kind of identifying where your subquery starts. So I'm just going to do that. So this SQL knows it's going to run this query first, get back that result of 1, place it inside of the outer query, and get that result. So if I click go, I get back the same as what we did before, all of the movies with the genre ID of 1. But we used a subquery to do it. Okay, and that's kind of how subqueries work. And that's essentially what we have here on this slide. Any questions? All right, there's no questions. That pretty much ends what we're talking about for SQL in this lecture. Again, we'll talk more about SQL next lecture where we continue on. We talk about the non-select queries as well as some additional statements and clauses that we use inside of SQL. Let's go ahead and take a look at the assignments that are your assignments for this week. So the first one is the Movie Mayhem 1 assignment. This is a GitHub Classroom assignment, so you will need to accept the assignment on GitHub Classroom and clone the repository. You'll want to import the Movie Mayhem database. Now that was the database I was just demonstrating to you, as well as all the slides that you saw here today was from the Movie Mayhem database. Now there are tasks. I believe there's 7 tasks for the Movie Mayhem 1 assignment. For each task, you're going to write 1 query. And that 1 query should bring back the results that you want for the task, to complete the task. You'll use phpMyAdmin to run each of these queries. You'll save each query to the queries.sql file, which is inside of the repository. And then this will be due next week. Now, there is already a solution video available on the assignment page for this assignment where I walk through completing each one of the tasks. And I go into detail on how each of the queries work as well. All right, that's Movie Mayhem 1. You also have a new hybrid assignment for this week. The hybrid one, by the way, is due today. So if you haven't watched those videos yet, make sure you do that and submit your reflection. For hybrid 2, you're going to be watching the entire course of MySQL Essential Training. There are 6 sections for that. So you want to go through each 6 section, and then you're going to write a reflection for each section. So after you completed a section, just write a reflection on what you learned. And this one is going to be due the 24th. Okay, so that is due the 24th. Then your last assignment for this week is the Sociology DB 1. Again, this is a GitHub Classroom assignment. You're going to import the Sociology DB database, which I'm going to demonstrate here right after this slide. Then again, you'll have some different tasks. For each task, you'll create one query to complete each task. You'll use phpMyAdmin to run your queries, and you'll save each query to the queries.sql file. And this is due on June 24th, so you have 2 weeks to complete that. All right, so let's go ahead and let me show you how to import databases using phpMyAdmin. All right, so I'm gonna come here. I'm gonna log out again here. All right, so I can't really see my nav bar, but hopefully you can see my nav bar. But if you are on a Mac, to get to phpMyAdmin, and this is phpMyAdmin installed on your machine. This was part of the Laravel development tools. You were to install phpMyAdmin. On a Mac, you would go to phpMyAdmin.test. That would get you to this login screen. If you are on Windows, you would go to, this won't work on my machine because I'm on Mac, but you go to localhost phpMyAdmin, and that will give you to the phpMyAdmin on Windows. By the way, I demonstrate that on the solution video for Movie Mayhem too. Once you get to the phpMyAdmin login, you'll use the username and password root. Again, that's assuming you followed the Laravel development tools for setting the username and password. So it's root for both username and password. Okay, just save that so it stops popping up. And then once you get here, now my screen is kind of small, so this is sort of in the mobile version. So you might see something slightly different, but this is kind of the beginning spot for your phpMyAdmin. Now up here are your different tabs for getting to different items. SQL is where you'd write in all of your SQL statements. But right over here is the import tab. The import tab is where we would import our databases. So we'll want to click on that tab, and then you'll be given to this screen. Now, you will choose your file. The file you want to choose will be an SQL file, and that is inside of your repository. So both Movie Mayhem, the Movie Mayhem 1 repository and the Sociology DB 1 repository will have their databases in it. I have the Sociology DB 1 already opened, and you can see right here is the Sociology.SQL file. This is the Sociology database that you will be using. And so you can just choose this file. So I'm going to go ahead and click choose file. And this will open up, and I'll just navigate to that file. So I've got it here. And here is my Sociology DB1 project. And here's my Sociology.SQL file. And I'll choose that. Once you've chosen that file, you can go down and click Go. This will create the database for you. Might take a moment, and there we go. So once it's done, and you should get all nice green arrows or green check marks all the way through, then you can go to databases, and you should have the Sociology database available under your database list. Now, take note that I have a lot more databases than you will probably have because I've been doing this for a while. I've got a lot of stuff going on. But as long as you have the Sociology and Movie Mayhem database, you should be good. And then you can click on those databases to check your data. And once you have that selected, then you can go to the SQL tab to write your SQL. So that's how you kind of get started and installing your databases. Now, we will be using the Movie Mayhem database and the Sociology database for 2 assignments. So next week we'll have assignments. You will not need to re-import them because it's the same database. It says it in the instructions to import it, but that's just assuming you hadn't already. It is the same database, so you don't need to import it again. All right, so we got some questions, some warnings down at the bottom. So sometimes, so sometimes they'll say something, PHPMyAdmin will say that securities have some security warnings. As long as you can get logged in, you don't have to worry about it. If you can't log in, then it's a problem, and I'll help you address that. All right, any questions about working with databases, writing your SQL, working with PHPMyAdmin, or your assignments? Okay. Let's talk about next time. So next time we are going to be covering non-select statements. So that's your insert statement, your update statement, your delete statement. We'll also be talking about joins, which allow us to combine tables together inside the results. And we'll be talking about functions. So SQL also has functions that we can use to kind of aggregate data together. We'll have a participation assignment, Movie Mayhem 2, as well as an exercise, Sociology DB 2. Right? So that is what we're going to be learning next time. Any final questions before we wrap up? Okay, hopefully I didn't put everyone to sleep. That is all I have. That concludes our lecture. Oh, we got a question? Nope, no question. Okay. That's all I have. Good luck on your assignments, and I will see you next time.